Hello, my name is Bokor and I'm a PhD student at Northumbria University in the UK. I co-wrote this paper titled Using Artificial Neural Networks to Model Bricklaying Productivity with my supervisors. First, I would like to introduce the study, then talk about the steps of the model development, and finally some words on how this model will be used in the future. The construction industry has long been critiqued for not having a large enough productivity growth or for not having one at all. And also there's a skill shortage that has been present for a long time now as well. So for these reasons, it's important to study labor productivity. There are many factors affecting productivity, and they act on their own and also together with other factors. There are interdependencies between them, and together they form a complex system. Therefore, ANN or artificial neural networks are very appropriate to model construction productivity because they can handle these uncertainties and complexities, and they are able to learn from data and make generalizations based on them, and so they can predict outcome based on the input. In this study, we concentrated on factors whose values can be known before the construction happens, so in the pre-planning phase of the projects. These factors are design-related and worker-related. These define the input variables that our model will have. The next step is the data collection. So two construction projects were chosen in the UK. Work studies were conducted at these projects. So observations were ongoing for several months on each project. The values of the input variables came from different sources. So the values for the worker-related variables came from the site managers who evaluated the bricklayers, and the values for the design-related factors, the wall-related factors, came from the drawings. The next step in defining our model is to define its type. So supervised learning was chosen in the case of this model because we had the values for the input variables and also for the output variables. So we measured the productivity rates, and both of these sets of data were fed into the network. Feed-forward backpropagation was used, as this is one of the most popular network types, and also for its accuracy and high interpolative performance. The variables used are static, so they are not changing over time, and the output of the network is deterministic. The next thing to determine is the network architecture. So we have three different types of layers. There's the input, the hidden, and the output layers. There could be one or more hidden layers depending on the network. We have as many input neurons as input variables. So in our case, it was 7. We had 5 worker characteristics and 2 wall characteristics. There is only one output neuron, and that is the forecasted productivity rate. The number of neurons in the hidden layer are determined in an iterative way. So first we can start with around 2/3 of the number of input variables, and then it can go up as high as 2.5 times the number of the input variables. Having this number right is important, because if we have too few hidden neurons, then underfitting can occur, which means that there would be big errors in the output. And if we have too many hidden neurons, then there could be overfitting, which means that the error is not high, but the network doesn't work properly outside the training patterns. So in this case, the signal comes in to the input neurons. Then through these weighted connections that you can see on the figure there, it gets to the hidden layer, and then through weighted connections again, it gets to the output layer, and finally there's an output, which is the forecasted productivity, as I have mentioned before. There are also biases involved. And in the calculation of the inputs into the specific neurons, also transfer or activation functions are taken into account, which will come later in the workflow. So the training algorithms that we use are calculating the weights and the biases in the network. We have chosen to test these 6 different learning algorithms. They were all chosen for their speed and efficiency. For example, Bayesian regularization is ideal for small and noisy data sets, or an adaptive learning rate can help improve the performance of the network. And then the transfer functions can be chosen. So sigmoid functions are the most common. They resemble the behavior of the biological neurons as well. Also, linear functions are used, so different combinations of these functions were trialed while making the model. And then when we have one network configuration set, then it's trained and tested, and the correlation coefficients, the mean squared error, the mean absolute percentage error are all calculated. And then we can determine whether these are acceptable for us for this model or not. If these are not acceptable, then we need to make some changes. We have 2 options. We can either modify the settings. So anything that was mentioned before, we can have more hidden neurons, we can have fewer hidden neurons, we can have another hidden layer as well. We can choose a different training algorithm, or the learning rate and the momentum of the training algorithm could be changed. We can also change the transfer function, a different sigmoid or linear function can be used instead. So after all these changes, we also have another option, which is retraining the network. It means that we retain all the same settings, but the new weights and biases will be calculated by the training algorithm. In this study, hundreds of networks were created, all with different network settings, different network configurations. And then these were evaluated and compared to each other based on the performance measures that we picked, so the correlation coefficient and the error measures. And then at the end, we could find one that had the best performance with respect to these measures, and which is the best that we can achieve with this data that has been collected. And we can use this network then to do sensitivity analysis to find out which factors and how affect productivity. And then in the future, this model will be part of a hybrid model where the output of the ANN model will be the input into a discrete event simulation model, where the bricklaying process is simulated and the activity duration of the bricklaying task is the output of the ANN model. By better understanding the effects of the chosen factors, hopefully we will be able to make more realistic schedules, and also it will lead to better resource allocation as well. Thank you very much for your attention.